Hi and welcome. So you probably thought you escaped the belt sander project, but guess what? It's back with a vengeance because the dust collection issues become a problem. So here you can see just all the debris collecting in the base here, and I need to do something about it. So for starters, I laid out and had a guy at work print in two pieces this 3D printed part. It's got a 1-inch diameter shaft there and two slots that are 1/4 inch wide. And this guy fits perfectly in here and will be held in place by this piece, which I made off camera, and it just screws in right there. And I need to make the interface piece to the vacuum that's going to attach to this. So that's what we're doing this week. We're making the vacuum piece. And then, of course, I got to clean all that debris out of there because this is a really tight fit. It's amazing what you can do with 3D printing. These two pieces are epoxied together. He put registration pins and holes on both sides. Pretty impressive. So let's head over and take a look at the interface to the vacuum cleaner. Okay, so this design sort of evolved. Originally, I tapped these holes, and they're at a 45-degree bolt hole angle. And I tapped them because I thought I was going to come from whatever interface I made and go this way. But in fact, we're going to screw from this side going not into this piece, which will become my vacuum interface. So I've got to drill these out for body drill, which shouldn't be a problem. And then I've got to relieve this side for some low profile screws, because the screw heads are going to be sticking into the plastic a little bit. So I've got to drill that out, relieve that for those screw heads. So we'll do that too. And then the design is kind of weird. It's basically going to sit at an angle. Let's see, do I have one? Yeah, here it is relative to the piece. So that's upside down. So the piece will be sitting on the belt sander. That's this piece right here. And it'll be sitting on the belt sander and canted at an angle, and then you will put your vacuum hose in here. I figured out the taper of the vacuum hose, so that shouldn't be too bad. And we're just going to cross drill this piece of Delrin here and make the tool. And what I might end up doing is taking the square part here and make it round later. I haven't decided to put it back in the lathe and round that off. I mean, there's no reason for it other than it might look interesting. So we'll see once this guy's in. We'll do that for fun. So next, I've got to just mark a position because we got to hold this in the 4-jaw chuck, and it's going to be eccentric. This is 2.5 inches by 2 inches, but we want it centered on the 2-inch square right here. So we're going to do that. So here's an interesting observation. I always clean the lathe before I put it to bed for the night, even if I'm working on a project. I almost never leave chips in it. But one thing I do is I always oil the ways, with the automatic oiler and sometimes by hand. But when I leave the lathe, before I do anything, before I even move the cross slide, I try and remember to wipe off the ways, because overnight dust is settling, and if there's any grit in that dust, that causes a lot of wear. Apparently, just dust and dirt in the air is the primary wear factor on a surface plate. So I find that I do not move the cross slide until I first wipe the ways off, all the oil and the grit off the ways lightly. And I'm thinking that might prolong the life of my ways. I might be wrong about that. That might not be even a major source of wear, but it takes very little effort, so I'm continuing to do that. Alrighty, so this guy, I just scribed a center point on here, and I used the live center just to press it up against my chuck body. And then, because this is offset, I'm just walking my jaws in just till they lightly touch for now. This isn't a precision. If this was a precision operation, I would have to get this lined up a lot more carefully than just using a scribe mark. But it is not by any stretch. It's for where the center of the hole is for the vacuum. So not a big deal. So I'm just going to snug these a little bit. And then I'm going to take an indicator and walk through here and center this, because we are going to be drilling a hole almost this entire depth, almost 4 inches, 3.75, and then we have to do the taper. Let me grab an indicator on here And when you're indicating in something that's square like this, you got to go for the low spot. Okay, that really is the low point at 0 there. So we're going to take this, rotate around. Boy, barely makes it. Shoot for the low point. So that's 6 thousandths. And so it needs to come this way. So I'm going to loosen this the tiniest amount. And I got to remember, I got to always pull this back to rotate or I'm going to destroy my indicator. And we sort of wanted half the distance, so let's see. That might have been too much, but let's make that 0. Wow, we're within 1,000th. That's more than accurate enough. One more thing, which I'm not particularly worried about for what this is, but if I cared about the surface finish of this material, I would have put some flat pieces of material between the vice jaws in here because they will mark it. The beauty of Delrin is the stuff cuts like butter. It's just a total pleasure to work with. Using the DRO on my tailstock to do this. If you're wondering about that, I have another video where I make that. Very handy. This might be a mistake, but I'm going to try and go straight from the slightly over 1/4 inch. It was actually a metric drill of something like 8.5 millimeters. And I'm just going to go see if I can go straight to the 1 and this is 1 in 7/32. The actual size is not particularly a big deal. This is a very sharp drill, which is one of the reasons I want to use it. This is still smaller in diameter than the rear of the taper, which is key. That works out pretty well. And we will bore the taper. I made some big boy chips, except it's out of plastic, so I guess that loses the big boy title. I can pretend though. One thing I thought of is the back of the bore is conical now, shaped like the drill bit, which is actually quite a big cone. So what I thought I would do is, this is a carbide boring bar with a positive rake insert, even though it's tilted at a negative angle. It's for aluminum. It's very, very sharp. And I'm hoping, normally this would be way too much stick out for this to deal with, but I'm hoping that because this is just plastic, I will be able to bore this out flat in the back. Here's that boring bar in its entirety. It's a solid carbide shank with a steel end part brazed on, which makes it really stiff, which makes you get away with things you couldn't ordinarily get away with, like the 4 inches of stick out I had on this guy, which it's not made for, but cutting pressure is pretty light. Alrighty, so I made this adapter plate that has magnets on the bottom in one of my videos that attaches to my compound to let me set the compound angle accurately. And this angle is 1.18 degrees, so it was a bit of a challenging. It's 0.103 thickness for the gauge block in here, 5-inch sine bar. And then I just keep tapping around till as I move, the indicator doesn't move at all, and you can see that the indicator is engaged there. I've just dialed it in before we got there, and it's pretty much right on the money. So once I've got that, I can lock my compound down, and I can use my compound to go in and do that angle. If you're wondering about this adapter, it just attaches with magnets right there. It's got a lip, everything's ground, so this surface is ground, this surface is ground, this surface is ground, so it's as accurate as I can make it. This isn't a really precision job, except that when you're trying to match a really narrow taper of something like a nozzle for a vacuum, it can become challenged. This particular vacuum cleaner is an old fine vacuum cleaner that I've never want to get rid of because it's pretty fantastic. And that really should be it. Next thing is just to test the vacuum cleaner nozzle on it, see how it fits. Wow. Couldn't ask for a better fit than that. That's fantastic. That won't fall out. That's a friction fit on its own. Absolutely perfect. All right, moving on. All right, so before I didn't want to remove any material to make it easier to turn the chuck, but now I got to take a 1/2 inch deep cut back to make this square 2x2. And I'm just going to put an approximate line back here, and then I'll measure my way into the final setting. So I'm going to set my calipers to should be 2 even, which it is, 1/2 thousandth over, and we're going to set this to 2.50. And let's see if I can see that line. I want to work up to that line, and then I will go and remove the rest of the material, and we're basically going to go down until we've taken out about 1/2 inch of material. Nothing is precision here. The bolt circle will have to be fairly accurate, but other than that, not much else. So we're just going to take off. We're going to go 1/4 inch deep, and I'm just going to come up to this line, and then I will hey, look at that. My dirty fingers mark the line nicely. That's pretty good. Got to get it out of neutral, of course. And we're there. So as long as I've got this face mill on here, might as well, the only problem with plastic is it's statically charged. As long as I've got the face mill on here, I might as well, since this is going to be canted at an angle, at a 55-degree angle, I got to remove some material. So I need to space this guy by 55 degrees, tilt it at 55 degrees, and then remove some corners and some edges just a little bit, and that'll make it so that these corners don't stick up on the belt sander itself. Again, not a precision setup. So I've got this clamp pretty hard in the vise, and just use a couple of angle blocks here. It was a combination of a 20 and a 30 and a 25 to give me 55 degrees, and I think they're magnetized. Look at that. I don't think they're supposed to be, but actually that helped. They stuck together really nicely. So we got this guy at 55 degrees, and we can remove a little bit off this side and a bunch off the top here. And hopefully the force will be in the back jaw so this thing won't kick down, because there's nothing supporting it. So if it was a, if this was a harder material, this could be a serious problem. We're going to take off the extra material in a couple of passes. We got to go a total of 0.4380, so I'm just going to do 100 thousandths passes. Then we just need to remove a tiny bit off of this corner over here, perpendicular, and I can use the edge of this cutter because it's mostly perpendicular. It's not perfect. I normally rely on electronic edge finders, but on Delrin, guess what? They don't work. Did anyone else notice what I was doing when I was really sucking here? Because the corner that was supposed to come off was not this one. It was supposed to sit like this, and this corner was supposed to come off, and this corner here, not this one. That's part of my face, and I have just hosed myself big time. All right, so I remade the piece and drilled a little bit deep, just a fraction of an inch, and it blew out there, but that's okay. I can deal with that. You can see now that this is in the right orientation, small, big slot. Now I'm going to do the 1-inch hole to meet up with the other hole inside, and I'm going to use a rotoburr, or rotobroach rather. I guess that's an annular cutter, since this is not an actual rotobroach. And we're going to go pretty slow. Okay. That sucked itself right in the hole there. That's some scary shtick on there. Okay, we are clear. Yeah, I just went a little bit deep when I cut the other thing, but the 1-inch hole is good, and I've got my 0. So the next thing we're going to do is we're going to drill and tap the bolt circle around here, and it's shifted by 10 degrees. And I'm going to use the DRO to take care of that 10 degrees. The DRO is really handy for that, because the DRO, you can tell it to start at 10 degrees if you want, which is what I'm going to do. Well, I matched the drawing perfectly this time, except for getting this one hole a little deep. And guess what? My drawing had this placed mirror image, so it's actually rotated the wrong way. I thought it was going to end up going like this. Let's see, something like this right here. And then the holes would sort of line up, but actually that's still not correct. All the holes were supposed to be contained inside, and they aren't, because I blew it. Because this is actually the way it's going to go. So I've got several options if I want to make this one work. I can do it square, where it points straight down, and get 3 of the screw holes plus a through hole, which is probably okay. Boy, this is really disappointing that I screwed this up. I wanted it shifted, you know, about like this. And if I did that, you can tell that I cut off the bevel on the wrong side. It should have been over here. The bevel was cut off right here, and only a little bit on this side. So I got exactly the mirror image. So my bevels, again, cutting them, hosed me in more than one way. So now I need to figure out how to, I either need to remake this part again, which I'd rather not, or I guess I can just have it come straight down, and I'll hit several of the holes till I can remake this part again. I need to get some more Delrin, because I am now out. My holes were pretty close, or my marks were pretty close. I'm going to drill the through hole for the 1032 that attaches this to the side. Okay, there we go. Thought I wasn't going to make it. Just barely cleared. Alrighty, so this project's been nothing but a comedy of errors. I almost didn't even think about editing this into an actual video because there were so many mistakes, but you know, maybe someone can learn from my mistakes. So I've got to get some more Delrin to make this part over, and I popped this guy in the lathe and rounded off this square section here because it just seemed nicer, and that I do like the way that turned out. Mistakes I've made. The reason why this got cut into was not because I went deep. I checked the depth on the drill bit, and actually I cut this to the exact right depth. But what I did do, remember, as I was talking as I was going, oh, I'll just open this up bigger than 1 inch because that'll let more air flow, so there's no problem with bigger than 1 inch diameter, even though I laid this out in my drawing at 1 inch. So with the larger diameter in here, it came out farther to the side, and I ran into it. 1 inch, it would have cleared. In my drawing, it just barely cleared. Now it didn't clear, of course, when it's 1 1/4, a little over 1 1/4, it didn't clear at all. This part, the reliefs on the two sides here, They're mirror image because when I did the drawing, I wasn't paying close enough attention to the fact that this goes on to the belt sander like this, and this part sits here. I laid it out as if the part was coming from the back, which makes it a mirror image, which is why I put the slot here. So if you tilt it to an angle, it would be right. But that's not doing anyone any good. I've relieved this guy in the back so that these screws will fit flush. And when this presses up against this piece over here, they won't touch, which is good. I made a custom thumb screw that's going to go all the way through this part and hold this thing in. This is just some threaded rod that's Loctited into a brass piece here. And let's see, what else? Yeah, when I get more Delrin, I'm going to remake this piece because it kind of bugs me, and I would like it at an angle. Also, another thing that I didn't think of, I made this piece first a while ago. Sort of made this thing in pieces. I said, okay, I'm just going to design this, and just laid it out as is. And I didn't plan on any of the other parts, and here's one of the problems when you don't do that. The bolt circle on this is 1.5 inches. What I really needed for this guy was a bolt circle of 1 1/4, which would have put it fairly close to this edge and kept them all within the cut off pieces. That was another mistake I made, and since I wanted to reuse this piece, I had to make the bolt circle 1 1/2, which means I couldn't do the 4th hole there. If I'd used 3D CAD, all these problems would have been probably very readily apparent, but I didn't. So that's my bad. I've got to get better at AutoCAD Fusion 360. I have another one. I have BobCAD, but their support is horrible. They want to charge you for their own patches where they're fixing their own bugs in the software, and it's incredibly buggy. You do something one time and select on it, and it works. The next time you can't select on it for unknown reasons. All kinds of issues like that. So I'm not a big fan of BobCAD. I paid them the couple $100. And then they constantly bug you trying to sell you on an upgrade. But my opinion is if they don't fix their bugs, you know, they're not worth this. They're not worth anything. All right, so let's just assemble this guy. So this is the back, and this guy goes like this on here. All right, just getting the last screw here. And just thinking back on this project, it started out, you know, flawlessly. The 3D layout of this thing worked out perfectly, and I mean, this thing was such a close fit. I need to only remove just the ridges off of because the 3D printing leaves ridges. I just need to remove the ridges, and this thing's snug. This thing won't. I was worried that I was going to have to really hold this guy in place. It doesn't move at all because it's a really tight fit. Very nice. And I didn't think you could do that with 3D printing, but my friend who did the layout, who I made nozzles for in the past, he did a great job on this. I gave him a 2D CAD drawing. He did the 3D layout. Anyways, let's head over to the belt sander and see if we can put this guy on. One more thing before I head over. If you haven't heard of these shear lock thumb screw knobs, they're really handy. They fit on top of a regular Allen head bolt. And you just take them, I put it in the vise, and I just press these on. They're a press fit, but they're really tight. And you make an instant thumb screw out of any screw or bolt you've got. They come in a huge variety of sizes, and they're very reasonably priced compared to regular knobs. Now, granted, they won't be anywhere near as sturdy as a regular knob, but I haven't had a problem with them popping off at all. So anyways, just throwing that out there. Might be something useful in this video for you. All right. So it's pretty straightforward. All right, let's see if this guy slides in here. I think I should be able to change the belt with this in place. See how flush this is? Look at that fit. That is amazing fit. And then this guy goes on here just like this. Oh, look at that. A little strain relief. It's almost in the way. Not quite. All right, let's see if we can screw this guy on. All right, so there's one side. And this other side fits so closely, it should make a decent enough seal that I won't have any problem. Alrighty, there's the dust collector installed. And, you know, just for curiosity, I wonder how hard it would be to take the belt off. Oh yeah, no, this is going to prevent the belt. Well, it's only 2 thumb screws, fortunately, so we can get the belt off pretty easily. If I was going to swap the belt a lot, then I guess another modification of this is to put a radius in this plate here so that the belt could come off, because the belt does slide past this. There is enough clearance. All right, so there's the, I actually like straight down. I thought I wasn't going to like it, but it's good like that. I may do the next one square. And I think we're looking good. Normally it would be full of debris in here. There's only a couple little bits. I think it's working quite well. We'll have to clean out these upper levels and see what happens long term. But I think we're good. Anyways, for a semi-failed project, thanks for watching. Hope you find it useful. Hope to see you next time.